So first of all, I would like to explain how refrigeration system is work. So first, refrigeration system remove heat from a low temperature area and release it into a surrounding. It works through a four main components: compressor, condenser, expansion valve, and evaporator. So refrigeration system is also important in industry. Refrigeration is essential in industry such as food processing and manufacturing. It helps preserve product, maintain quality, and ensure efficiency in industrial operation. So next, this is a main component of the refrigerant. So I will explain the function of each component. First, a compressor. It draws a low pressure refrigerant vapor from the evaporator and compress into the high temperature vapor. Next is condenser. Reject heat to the surrounding and convert the refrigerant from high pressure vapor to high pressure liquid. Next is expansion valve. It reduces the refrigerant pressure suddenly, causing a drop in the temperature before it enters the evaporator. And lastly is evaporator. It absorbs heat from a space being cool, causing the refrigerant to evaporate into a low pressure vapor. Next is a mechanical analysis of the refrigerant system, and we're gonna look at a graph, pH graph. So we can refer each point of the cycle. So it starts with a compression process, point B to point C. Condensation process, point C to point D. Expansion process is point D to point A. And lastly is evaporation process is point A to point B.
Next, we have mechanical problem. Fouling happens for several reasons. Firstly, we have environmental accumulation. Dust, pollutants, and debris get trapped in the condenser fins. And we have scale deposits. Mineral buildup from untreated water creates insulating layers inside. And then we have corrosion. Rough oxidized fins attract and hold even more dust. Lastly, we have maintenance neglect. Without regular cleaning, small blockages become thick, hard layers of debris. And we have risks. Risks are significant. Firstly, we have mechanical failure. High pressure causes compressor overheating and breakdown. Second, we have safety hazards. Excessive pressure can trigger emergency relief valves, releasing refrigerant or causing shrapnel injuries. And then we have operational inefficiency. The compressor uses more electricity, wasting energy and raising costs. Regulating non-compliance. Operating outside design limits violates safety standards like ASHRAE 15 and energy laws such as Environmental Quality Act 1974. So next, I will explain about slide 6 shows the pH diagram for condenser fouling. Pressure on the vertical axis, enthalpy on the horizontal axis. In a normal system, the cycle follows this path, but with condenser fouling, three things happen. First, higher condensing pressure. The top of the cycle shifts upward because the heat can escape. Second, more compressor work. The longer distance here means the compressor uses more electricity. Third, less cooling effect. The bottom part gets shorter. The result, lower efficiency, which is more energy in, less cooling out. Cleaning the condenser restores the cycle to its normal shape. The pH diagram makes an invisible problem visible. Fouling isn't just dirt on fins. It fundamentally changes the thermodynamics of the entire system.
Slide explains safety regulations related to refrigeration system. According to ASHRAE Standard 15, refrigeration equipment must be operated and maintained safely. Regular condenser inspection are important because the faulty condenser can increase pressure and lead to equipment failure. In Malaysia, both the Occupational Safety and Health Act 1994 and the Factories and Machinery Act 1967 require employers to maintain refrigeration equipment in safe operating condition. To ensure safety during the maintenance activity, personal protective equipment such as safety helmet, Google gloves, and safety shoes must be worn. The slide shows the safe work procedure for handling condenser fouling. The refrigeration system must be shut down and isolated using local take-out procedure. Workers then wear the required PPE before the starting maintenance. The condenser is inspected and cleaned to remove the dust, scale or the other deposit that reduce heat transfer. After cleaning, pressure testing and leak detection are carried out to ensure the system is safe and leak-free. System in evacuate, recharge with refrigeration is targeted and monitored to confirm proper operation. This procedure improves efficiency, reduce equipment failures, and ensure compliance with safety regulation. The proposed engineering solution is preventive maintenance program that includes regular cleaning, pressure monitoring, and performance inspection. Following reduce heat transfer efficiency, causing higher condensing pressure and increase the compressor workload. By cleaning condenser surface regularly and installing pressure gauge and temperature sensor, problem can be detected early before the unsafe condition occur. The solution improves the cooling performance, reduce energy consumption, and extend equipment lifespan, enhance workplace safety, and ensure compliance with industry standard and improve environmental regulation.
Now I would like to present about Phase 3 Sustainability and Impact Environment. Although condenser fouling does not directly cause refrigerator leak or affect ODP and GWP, it creates significant indirect environmental impact. Fouling reduces heat transfer efficiency and forcing the compressor to consume more electricity to maintain cooling performance. Since electricity often generated of fossil fuels and increase carbon dioxide emission and system carbon footprints, rules cleaning and maintenance restore efficient heat transfer, improve the coefficient of the performance, reduce energy computation, and lower greenhouse gas emissions. Therefore, controlling condenser fouling is an important step towards improving energy efficiency and environmental sustainability. Next, I would like to present is societal and economic. Addressing condenser fouling provides significant environmental, economic, and safety benefits. Fouling reduces system efficiency, causing higher electricity consumption and increased indirect carbon emissions from fossil fuel-based power generation. By restoring condenser performance, therefore COP improves, reducing energy cost, maintenance expenses, and equipment while extending its lifespan. In terms of safety and cleaning, condenser lower operating pressures and temperature, reducing the risk of compressor failure and workplace accidents. Overall, eliminating condenser fouling a sustainable energy solution that improve efficient exchange safety, reduce environmental impact, and supports long-term economic performance.
From a legal perspective, rectifying condenser fouling helps ensure compliance with relevant Malaysian environmental and safety regulations, improve condenser performance, reduces energy wastage, and promotes efficient use of resources, supporting the objective of the Environmental Quality Act 1974. To minimize environmental impact, lower energy consumption also aligns with energy efficiency initiatives aimed at reducing greenhouse gas emissions and promoting sustainable industry operations. Furthermore, maintaining refrigeration equipment in a safe operating condition helps organizations meet their responsibilities under occupational safety requirements, reducing the risk of accidents, equipment failure, and regulatory penalties. Therefore, addressing condenser fouling is not only a technical necessity but also an important step forward legal compliance and responsible engineering practice. In conclusion, condenser fouling is a major hazard in refrigeration system because it reduces heat transfer efficiency, increases condensing pressure, and causes higher energy consumption. To solve this issue, regular condenser cleaning, pressure monitoring, leak detection, and proper refrigerant handling should be implemented. These measures improve the system's coefficient of performance, reduce operating costs, and extend equipment lifespan. They also enhance environmental sustainability by lowering electricity consumption and carbon emissions. Most importantly, they improve workplace safety and ensure compliance with Malaysian regulations. Therefore, rectifying condenser fouling benefits safety, efficiency, environmental protection, and overall system performance. Thank you.